Imagine this. You're running a bank. Customers are coming in, opening accounts, applying for loans, and requesting credit cards. Everything's going smoothly until, suddenly, the same bank officer is juggling multiple tasks, handling loans, checking account balances, processing credit card applications, and more. The queue is building up. Things are starting to slow down. You need a solution, and fast. So someone suggests, let's break up the tasks. We could have one counter for loans, another for credit cards, and a third for account management. Sounds pretty good, right? It's more organized. But there's one catch. Every time these services need to communicate with each other, it creates some friction. And that friction can slow things down too. Today, we're diving into monoliths versus microservices. Let's break it down. A monolith is like your traditional single-counter bank. Everything happens in one place. Loans, credit cards, accounts, all the processes are connected. Take a look at this architecture. You see this big box? That is your entire application, your Spring Boot jar file. Inside, you have the loan logic, the credit card logic, and the account logic all sitting together in the same memory space. They all talk to this one single shared database. It looks simple, right? And it is. Communication here is instant because it's just a function call inside the code. The bank officer can quickly access a customer's details and process their request seamlessly. But here's the catch. When something breaks, it's a domino effect. If the loan logic consumes all your memory or crashes the system, you can't access credit cards or accounts either. Sure, it's easy to manage, but if one thing fails, the whole operation suffers. Now let's consider breaking the bank into independent services. Here is what a microservices architecture actually looks like. Instead of one big box, we have 3 independent servers, one for loans, one for credit cards, and one for accounts. Each service is loosely coupled. If the loan service breaks down, customers can still apply for credit cards or check their balances. It's also easier to scale, like adding more loan services when demand increases. But notice something important here. Each service has its own database. This is the database per service pattern. This ensures independence. No one is fighting over the same file cabinet. But there is a catch: communication. In a monolith, checking a balance was instant. But here, when a customer applies for a loan, the loan service can't just look at the account DB. It's locked out. It has to make a network call to the account service to ask for the data. And networks, well, they aren't as fast as direct function calls. So a customer places an order, the loan service calls the account service, and bam, network delay. The result? Slower performance and more potential points of failure. So why do big companies do this? Because microservices shine for large teams. Each team can manage its own service. One team handles loans, another manages cards. They work independently. If the loan team needs to deploy an update, they can do it without disturbing the account team. That independence is worth the extra complexity. But for smaller banks or startups, managing network issues and data consistency can be overwhelming. So, here is a solution. Modularizing your monolith. Instead of diving straight into microservices, break your system into distinct modules inside the same codebase. You get the organization of services, but the simplicity of a single counter. The key is to start simple. Don't rush into microservices until your team and your needs demand it. We mentioned earlier how network calls block your threads and slow down your application. It's a huge pain point in microservices. But Java 21 just changed the game. In our next video, we're diving into virtual threads. It's a revolutionary new feature that lets your applications handle millions of concurrent users without breaking a sweat, essentially fixing the waiting problem we talked about today. If you want to write high-performance code, you need to see this. Hit subscribe, and let's speed up your back end.